Hi, everybody. Today we're going to review something that you did last year, but we're going to treat it as though it were brand new. Hopefully you'll catch on and kind of remember what you did last year. Okay, so what we're going to do is called completing the square. We're going to use the concept of the perfect square trinomials, which we talked about on a previous video. All right, so a perfect square trinomial would be like taking x minus 5 squared. And we talked about the fact that we could do square it, double it, square it. So x squared minus 10x plus 25. All right, square it, double it, square it. This right here is a perfect square trinomial. All right, we're going to write down the steps as we go along. All right, so the first thing we want to do is move the constant to the right. The constant is the c term. Okay, so your squared term and your power of 1 term will stay on the left. So in this case, we're going to add 38 to both sides. So I get p squared plus 14p equals 38. All right, the next step is to add half of b squared to each side. Okay, so in this case, half of b is half of 14, and we want to take that number and we want to square it. So what we're going to do here is add 49 to each side. So p squared plus 14p plus 49. The reason we're adding it to both sides is because we have to keep the equation in balance. Okay, so we added the 49 to each side. All right, our next step is to express the left as a binomial, 2 terms, squared. Okay, so we want a binomial squared. In this case, we can look at either half of 14 or the square root of 49. They will be the same. They have to be the same. Otherwise, this is not a perfect square trinomial. So p plus 7 squared equals, and 38 plus 49 is 87. Okay, next step. Square root on both sides. Okay, on the right, you're going to have plus or minus. Okay, this says plus or minus. All right, so square root, square root. When we take the square root of something, it just, when we take the square root of a square, it just pops out. So we have p plus 7 equals plus or minus rad 87.
Call from Stan Leviton.
Okay, Levittown is calling. I wonder what they have to say.
Call from Stan Leviton.
Okay, now we need to isolate the variable. All right, which means get the variable by itself. So we're going to subtract 7 from each side. Oh, hold on, let me see if I can make this stop. Okay, it stopped. They'll call back. They always do. All right, so p equals negative 7 plus or minus rad 87, which means we have 2 solutions. One solution is negative 7 plus rad 87, and the other solution is negative 7 minus rad 87. Okay, we have one more step if it's necessary. Okay, we want to simplify if possible. All right, rad 87, 87 doesn't have any perfect squares in it, so not necessary on this one. Okay, so there's your two solutions. All right, let's try a few more. Okay, I can get up to number 4. Someone tell me when I hit number 4 to move the paper. I wish. Okay, step number 1, get the constant to the right. So I have v squared plus 6v. Now I know I'm going to add something to that, so I'm going to put it into my equation as I write it, so I don't have to write it twice. So plus 59, positive 59, because I added 59 to each side, plus something. Now I'm going to take half of b, which is 3, and square it. So I'm going to add 9 to each side. Express as a binomial squared, so x plus 3 squared, either half of the 3 or the square root of the 9, equals 68. Square root on both sides. The x plus 3 pops out. We need a plus and minus right here, rad 68. I'm going to go over to the right now because rad 68 can be simplified. The largest perfect square in 68 is 4, and it goes with a 17. So 2 rad 17. So I have x plus 3 equals plus or minus 2 rad 17. Subtract 3 from both sides. So I have x equals negative 3 plus or minus 2 rad 17. The two solutions are now going to be negative 3 plus 2 rad 17 and negative 3 minus 2 rad 17. So there's my two solutions. Okay, same thing here, constant to the right. So a squared plus 14a plus something will equal 51 plus something. Half of b and square it, 49 to both sides. Expresses a binomial squared, almost wrote x. So a plus 7 squared equals 100. Square root of the left and square root of the right. Pops out, so a plus 7 equals, we need the plus or minus, 10. Subtract 7 from both sides. So a equals negative 7 plus or minus 10. Two solutions, negative 7 plus 10 and negative 7 minus 10. This will give me 3. This will give me negative 17. Okay. All right, next one. Constant to the right, so x squared plus 14x plus something equals 15 plus the same thing. Half of b and square it, 49 again. Expresses a binomial squared, so x plus 7 squared. 15 plus 49 is going to give me 64. That's nice, another perfect square. Square root on both sides. So I have x plus 7 equals plus or minus 8. Move your 7 over. Isolate your variable. So x equals negative 7 plus or minus 8. I'm going outside too much. Negative 7 plus 8. Negative 7 minus 8. Excuse me. That's 1, and that's negative 15. There's my two solutions. You know, if you wanted to, you could express your solutions like that. Okay, right here, constant to the right. K squared minus 12k plus something equals negative 23 plus something. Half of b and square it, so 6. I'm not saying the negative, which I guess technically I should be, but I know that when I square something, it's going to be positive, so I don't really worry about the negative on this. So 36 to both sides, binomial squared, k minus 6 squared equals, when I combine those two, I get 13. All right, square root on both sides. I'm going to go sideways. So k minus 6 equals plus or minus rad 13. Add 6 to both sides. So I get 6 plus rad 13 and 6 minus rad 13. Okay, and there's my two solutions. Okay, I think I cut 5 off. All right, so there, take a look at it. I'm pretty sure I cut 5 off. Sorry. Okay. For number 6, we have a 7 on the right, but we still have this negative 91 right here that needs to move over. So we're going to add 98 to both sides. 91, sorry, the answer is 98. All right, so I have r squared minus 4r plus something equals 7 plus 91 is 98 plus whatever that something is. Now half of b, again, I'm going to ignore the sign on this, so 2 and square it is a 4. Express as a binomial squared. So r, you're going to take this sign, and that's going to be a 2, either the half of 4 or the square root of 4, equals 102. Square root on both sides. So r minus 2 equals plus or minus rad 102. No perfect squares in that. So r equals, move the 2 over, the negative 2, so add it to both sides, plus or minus rad 102. So my two solutions are 2 plus rad 102 and 2 minus rad 102. Okay, now 7 is going to be a little tricky. All right, the first thing we want to do is get this 20k moved over. So I have 5k squared plus 20k equals 60. Now, this is kind of important. You can only do this, all right, completing the square, only with the coefficient, sorry, not just the coefficient, the leading coefficient, equals 1. So to get this to the leading coefficient on the squared term to be 1, I need to divide by 5. But I can, if I divide by 5 in one spot, I have to do it in all of them. So I have k squared plus 4k plus something equals 12 plus something. Half of b and square it, so 2 squared is 4. Expresses a binomial squared. Okay, that's nice. We have another perfect square there, square root on both sides. So I have k plus 2 equals plus or minus 4. Subtract 2 from both sides. So k equals negative 2 plus or minus 4. I have negative 2 plus 4, negative 2 minus 4. So right here, the answer is 2, and right here, the answer is negative 6. And I didn't box those either. Okay, so academic, that's what I have for you. Of course, you're welcome to continue the video and try these. They're a little challenging. Honors, you need to stay with me on this. Okay. So we're going to follow the same procedure, only there's going to be a little issue when we get to it. Okay, so I have k squared minus 4k plus something. I'm just going to move that 1 over, equals negative 6. Okay, half of b and square it. So we're going to add 4 to both sides. Okay, expressed as a binomial squared. So k minus 2 squared equals negative 2. Square root, square root. Okay, now, there is no such thing as a negative inside of the radical. What we're going to do is use what's called imaginary numbers, and it's really very easy, the concept. So the concept that we're using is the square root of negative 2 would equal, we take the negative and put it on the outside and turn it into an I, and that stands for imaginary. So it's I rad 2. Okay? It's a number that doesn't exist. Okay, so now k minus 2 equals plus or minus I rad 2. Okay, so the only thing we added here was that the negative comes out and becomes I, which stands for imaginary. Add 2 to both sides. So I have k equals 2 plus or minus I rad 2. This leaves me with 2 solutions. And it's going to be 2 plus I rad 2 and 2 minus I rad 2. Okay, so not so hard. Okay, constant is already on the right. So I have v squared minus 6v plus something equals negative 91 plus something. All right, half of b and square it is going to be add 9 to both sides. Okay, expresses a binomial squared. So v minus 3 squared equals negative 91 plus 9 is going to give me negative 82. Square root on both sides. Okay, everybody sees the negative is in the radical, so we're going to have an I here. All right, so the v minus 3 pops out, equals I rad 82. Add 3 to both sides, so v equals, oops, sorry, I should put that there. V equals 3 plus or minus I rad 82. No perfect squares in 82. So I have 3 plus I rad 82 and 3 minus I rad 82. Okay, now, this one is going to get really hard. Right, we have a leading coefficient of 2. So we have to divide each piece by 2. So I have x squared minus, I highly recommend that you leave these as a fraction. 5 over 2x plus 67 over 2 equals 0. Okay, so now we have a leading coefficient of 1. All right, get your constant to the right. So x squared minus 5 over 2x plus something equals negative 67 over 2 plus something. All right, now we have to take half of b and square it. As I said, we don't have to worry about the signs on it, because when we square it, it's going to be positive. Well, half of 5 over 2 is 5 over 4. Now, when we want to square that, we're going to get 25 over 16. So 25 over 16, okay? If you're going to take half of something, you can just double the denominator, all right? Because you're dividing it by twice as many, which makes it a half. And this is 25 over 16. Okay, express as a binomial squared. Well, this is definitely x. This is definitely minus. Right here, let me push up a little bit. Right here, we already did half of b. Okay, or the square root of c. Square root of 25 is 5. Square root of 16 is 4. Right, you see how nice that is with the fractions? I know you're not thrilled with them, but it is what it is. Okay, you can use your calculator for this, and you're going to get negative 67 over 2 plus 25 over 16. that's going to give you negative 511 over 16. Okay, so when you put this in your calculator, you're going to get a decimal and just do math, enter, enter. Square root, square root. Okay, when you're working with the decimals, you're not going to be able to simplify it all the way if you don't put it back into fraction. Okay, so x minus 5 over 4 pops out. And now is going to be plus or minus. We can't take the square root of negative 511. So this is going to be I rad 511. But we can take the square root of 16, which is going to be 4. All right, so that's going to be plus or minus I rad 511 over 4. Add 5 over 4 to each side, so I get x equals 5 over 4 plus or minus I rad 511 over 4. Now look, they have the same denominator. So one solution is going to be 5 plus I rad 511 all over 4. The second solution is 5 minus I rad 511 over 4. Okay, the homework is marked. You have to do all of it, okay, for honors. If you stayed with me for academic, you only have to do the first whatever it says there. Okay, all right. That's it. So hopefully you understood this, and we can go back and do the circles for the next lesson. All right, have a good day.